And we're starting our next session of dimension analysis. This session is all about performing simple dimension analysis conversions using our conversion table to our left. We're going to go ahead and start. Our first question is 75 meters. Please notice that meters is a length. We have a length unit to our left. Our conversions are actually grouped into three main groups. Length conversions are all grouped together. This is not a comprehensive list. We have the most popular conversions listed here in the list. We also have mass conversions, right? Or equalities. And then we have volume conversions or equalities, okay? They're called equalities because you have the same lengths measured using two different units. Okay, let's go ahead and continue where we left off. So we are starting with the first problem, which is essentially converting from 75 meters to feet. The first thing we want to do ideally is find a conversion, one conversion equality that connects both our given unit and our desired unit. So we have just one conversion or equality that takes us straight directly from meters to feet. When I skim over here, I see meters with kilometers, meters with centimeters and millimeters. I see meters with other units, right? I don't see meters with feet. Let me keep going. Let me actually skip and look at feet. I see feet with centimeters. I see feet with yards, feet with inches, and feet with miles. Once again, I don't see meters with feet. With that being the case, let me go ahead and select the 1 foot equal 30.4 centimeters. So I'm going to write that here. My conversion factor selected will be 1 foot equal 30.48 centimeters, okay? So how do I know this is the correct conversion to pick? It is correct because in the conversion, you have the desired unit showing up, right? With an intermediate unit. Now, as long as the desired unit shows up here, we're good. So we have the desired unit showing up twice. In the desired part, right here, foot, in the conversion equality, right? So we see feet showing up twice. I call this unit mapping. Then when you're trying to make sure you have the right number of conversions, make sure each unit appears twice. So of course, your unit has to appear one time as a given, and then you have your desired unit appearing one time as a wanted or desired, and then the same units have to appear again in the conversion factor, okay? So centimeter is neither given nor wanted. That means a centimeter is some intermediate unit, right? The next thing we're going to do is select a conversion factor that has the intermediate with our given unit. So I'm going to write here 1 meter equal 100 centimeters because the meter reconciles with the meter up here, right? So we have the meter showing up twice, centimeters showing up twice. Excellent. Now we can say we have the right number of conversions. First of all, the right conversions and the right number. And now we can go ahead and set it up. Are these the only conversions we can use? No. But these are the ones I chose, okay? So let's go ahead and go from here. We'll start with 75 meters. Write your given number with a unit. Do not copy naked numbers. Like whole numbers, naked numbers that have no unit. So it's almost like they don't have any context, right? It's important for us to have the unit right here on the top left so we know when we're using the conversion bracket, which I just drew, we know what unit must match diagonally to the right, bottom right. The units that are given to the top left must match diagonally to the bottom right. And that's how we set up the conversion bracket in dimension analysis. Since I have meters on the top left, whatever conversion I bring in, we must have meters on the bottom right, okay? I look at my conversion factors and only the second one has got meters in it. So I'm going to copy the 1 meter portion of the bottom and the 100 centimeter will go on top, okay? So my first conversion has been used. I cancel out my units that match diagonally. The meters are canceled. The next unit that directs our move will be the centimeter. So I go with that. Since I have centimeters on the top left, diagonally on the bottom right, I must also have centimeters. This is my last conversion right here. The centimeter portion has to go on the bottom. So the number 30.48 centimeters go with 1 feet and then 1 foot. Essentially, I have used this conversion here. Okay, so let's see. Okay, I didn't mean to erase that. I've used this conversion right here. The centimeter and centimeter cancels out. Let me erase all the arrows I have here. I don't want these to be in the way. Okay, so if you look at the math, the units have canceled out. Once we perform our actual conversion math, our number will then be in foot, which is our desired unit, correct? So let's do our math. The math is essentially 75 times 100. You multiply all numerator numbers, then divide by denominator numbers, 30.48, okay? Our resulting number will be in feet. So let's go ahead and work this out. 75 times 100 divided by 30.48. Multiply all numerator numbers on top, divide by all denominator numbers. So our answer is 246, right? 0.1 feet. But since our given number was only two significant figures, you will round up your final number to be two significant figures. The numbers on the left usually count towards the significant figures, okay? So this first position here has to count. It cannot be a zero number. It has to count. The second one also has to count. So this would be our first significant figure. This would be a second significant figure. From here on, we can't have any additional significant figures because 72 is only two significant figures. For that reason, we will drop off this number. Since this number is 5 or above, it has to round up. So our number will be reported as 250 feet. And 250 feet is the answer in the correct number of significant figures. I haven't gone over significant figure rules. I think I'll make a different video just for that. Okay, I'm applying them here without really going over why. Our second problem right here, problem number 2, I've already written it out. Let me write this to look more like a fraction, okay? So what I'm going to do here is write it as, it's going to be 3.33 kilogram. The kilogram goes with the numerator number, the default number, over 1 foot cube. So I'm usually told by students sometimes, oh, why do you have a unit by itself with no number? I can put the 1 here to give people peace without really changing the value or the magnitude of the number, right? Okay, we're gonna set up our conversion brackets here. I don't know how many conversions they will take. So I'm just gonna write this down like this. Okay, let's go ahead and break up the types of units we have here. We have numerators, right? Numerator units, so kilogram to ounces. If we go to our table, you see where the kilogram is right here? In the first row of the mass conversion, first row, first column, kilogram is a mass. And if you go over here, ounces is also a mass. So you see that we actually have kilogram. Oh, I see something over here. We have kilogram to gram, ounces to gram. We can use that. Or we can go kilogram to pound, pound to ounces. Let's actually use that one. Let's use something different. So we're gonna go for our mass conversion. Let me go back here and write this red. For our mass conversion, because we notice that our numerator is a mass, I'm gonna use 1 kilogram equal 2.205 pounds, okay? So that's this conversion right here. The kilogram maps up to the kilogram, and then the pound doesn't really map up to the ounce, so the pound is an in-between unit, an intermediate. So now I need a pound and an ounce, which I find right here. 1 pound is 16 ounces, okay? So let's check to make sure the units for the numerator shows up twice. We've already checked kilogram, it shows up twice. Let's check ounces. Ounces shows up here, shows up twice. What about our intermediate unit? It also has to show up twice. Pound, pound shows up twice, okay? Okay, now that we have that, now let's examine our denominator units, okay? We have feet cubed. In general, when we have length cubed, feet is a length, right? In general, when we have length cubed, volume is a length cubed. So I'm gonna write this right here. Volume, in general, is usually some kind of length cubed, okay? So feet cubed over here, you can see feet cubed is under volume. And then we have gallon. Gallon is also under volume, okay? So just like with everything else, we're now going to look at our volume conversions. So volume conversions. With our volume conversions, the question here is, can we find a conversion in the volume section that goes straight from feet cubed to gallon? I see a gallon here. I see a gallon here. See gallons. So far, I've seen 3 different gallons, and neither of them have got feet cubed. But the second row in the middle has 1 gallon equal 3.785 liters, right? So gallon will go with the denominator of our desired unit. Now we have to get the liters to connect to the feet cubed right above it. Great. We have 1 foot cubed equal 28.7 or 37. Sorry about that. 37 liters. Okay. Now that we have this, let's see. Our liter unit shows up twice. Our feet cube shows up twice. So we have all the conversions we need to convert. Let's go ahead and start. Now, in this case here, we have a derived unit, right? A unit over a unit. So you have an option to start from the top or the bottom. Let's go ahead and remix this one. We'll start from the bottom. So we're trying to get rid of feet cubed and bring in gallons. We're trying to go from the bottom, right? Feet cubed to gallons. We have to make sure diagonally across from where feet cubed shows up, we also have another feet cube here. So trying to make sure there is some number with feet cube over here. So go through your conversions. I see feet cube all the way down here. So I'm going to move that over 1 foot cube because the number that goes with feet cube is 1. On the bottom, I'll have 28.37 liters. Okay. So I just used the bottom conversion. I need to cancel out the feet cube so that it doesn't drive our next move. Our next move is driven by the liters on the bottom. We're trying to get to gallon on the bottom. We're not there yet. Now we're just at liters on the bottom. Since I have liters on the bottom, I have to have liters. I have it on the bottom left. On the top right, I have to have another liter. That's how this works, right? So I'm going to copy the 3.785, which is this number right here, and that is paired with 1 gallon, so 1 gallon. Do you see how we can now cancel out our liters, and now we have the gallon portion of our answer done and set up correctly? So we're trying to now convert the kilogram, the numerator unit, to ounces, right? Since kilogram is already in the numerator position, what you want to do this time is to get rid of kilogram. To get rid of kilogram, you have to make sure diagonally the bottom right, diagonally opposite from where kilogram is, you have another kilogram. I'm going to place the kilogram right here, okay? It's a little far, but it's still as effective, right? Okay, so while we have the kilogram here, we have to find a conversion that has kilogram in it. That makes it this conversion right here. So 1 kilogram, 2.205 pounds. Okay, it's a little tight over there, but you get the idea, right? We just use this conversion, cancel the kilogram and the kilogram out. Now we have pounds in our numerator, but we're trying to get ounces. So we have our last conversion right here. You have to put a pound on the bottom. So 1 pound goes with 16 ounces. And the pound finally cancel out. So let me highlight our units that we want. So we have ounces in the numerator as our desired unit. And then we have gallon in the denominator as our desired unit. So when you perform the math, multiply all the numerator numbers, divide all the denominator numbers. So it's going to be 3.33 times 3.785 times 2.205 times 16 divided by 28.37. Okay. When it comes to significant figures, I recognize there's so many numbers here, but we tend to go by the significant figure of the given number. So we want to start with 3 significant figure numbers. So our answer has to be rounded up or down into three significant figures. So we have 3.33 times 3.785 times 2.205 divided by 28.37. And so it looks like we have 0.9796, right? Ounces. So we have to round this up. So we end up with 0.980 ounces. And this counts as three significant figures. So 0.980, that has a non-zero number to its left and a decimal, counts as significant. So 0.9, the 9 is significant, the 8 is significant, and so is the 0, because to its left there's a non-zero number and a decimal. Okay, let's go ahead and continue with our conversions. This is going to be our third conversion. The third conversion, we're converting from 3.17 centimeters squared to kilometers squared. So we want to know what this is in kilometers, right? Kilometers squared. So if you look at the basic form of this measurement here, it's an area because we have length squared. Any length squared is usually an area. It's the form of an area. In our conversions, we have lengths, we have mass conversions, we have volume. We don't have an area conversion. So what we can do is find a length conversion and then square it to make our area conversion. So we are DIYing our conversion because we don't really have one. Does that make sense? So you're gonna try to relate centimeters to kilometers. Okay, centimeters to kilometers. And then once you get that conversion, then you will square it. So let's see if we have a centimeter to a kilometer. We have 1 kilometer is 100 meters. We have 1 meter is 100 centimeters. Do we have a centimeter and kilometer conversion? I see another centimeter here. I see a kilometer here, another kilometer, a mile. Okay, so let's say it's safe to conclude that we don't have a direct centimeter to kilometer, okay? So let's look at what we have here. 1 kilometer equal 1,000 meters, right? That's the conversion we have here. And then we also have 1 meter equal 100 centimeters, okay? But these are length conversions, not area conversions. Let's go through and square them to get our actual conversions that we need. So square everything but the equal sign. Square 1, square kilometers, square 1,000, square meters. And then rewrite your conversion. So when we do this, we end up with, let's see, 1,000 squared gives us what? 1 million, okay? So we'll rewrite this as 1 times 10 power 6, 1, 2, 3. Yep, 10 power 6 meters squared. So 1 kilometer squared. This is not useful to us anymore. It was now a means to an end. The next one we're going to square will be this one right here. Square the 1, square the meters, square the 100, square the centimeters, right? This is our way to get our square conversion. So 1 squared is 1. Meter squared remains as meter squared. And this is 4 zeros here, right? Centimeters squared. So we don't need this conversion anymore. These were all a means to an end. We have the 2 conversions that we need. This is essentially the conversions that we need. Let's go ahead and set it up. We'll include our dimension analysis brackets. We have 3.17 centimeters squared. Bring in dimension analysis bracket. We have that there. Remember, you have to match your units diagonally across from the original units. So we need to have a centimeter squared at the bottom. So we have 1 times 10 power 4 centimeters squared. That goes with 1 meter squared. In our conversion, the meter squared is the intermediate unit, right? We don't really need that. It's not our given or our desired. It's an in-between. It's our in-between on our way to our desired. So then here we have what? Since we have meter squared, we have to match that diagonally. We have 1 times 10 power 6 meters squared, 1 kilometer squared, okay? Now, for our actual math to get our answer in kilometers squared, we'll take 3.17, I guess it's times 1, right? Because these are 1. We don't have to waste our mental effort doing times 1. So just divide by the denominator number. Since we have scientific notation, use parentheses. 1 times 10 power 4, close parentheses. Divide again, divide by all bottom or all denominator numbers. 1 times 10 power 6. And so what do we get here? So it looks like I have 3.17 times 10 power negative 10, right? That's my answer in kilometers squared. Okay.